Okay, guys. Hey, Mr. Wood, back here for another lesson, continuing on in Chapter 2, just continuing review, and we're going to be reviewing formula writing and naming compounds. But we got to do jokes. Forget all this chemistry stuff. Here we go. Why shouldn't you give someone a gate? Because they might take offense. Offense. Riddle, what kind of ears do trains have? What kind of ears do trains have? Engineers. And then the final one, kind of a riddle too. What kind of teeth cost $1? Buck teeth. There you go. So that's probably the highlight of this video. Okay, I didn't get quite as far in some classes as I did others. So I'm going to... for some of you, this will be backing up, and I'll just go through this. So we're just going to go as far as we can, as long as we can. So here we go. Back to our notes. Okay, so, and again, I think in my especially period 2A cohort, I went over this, but kind of just the background is that chemical nomenclature naming compounds. And so back before there got to be, as you can see, those names say nothing about the substances, what the substances contain. To date, there are over 5 million known compounds. Memorization is impossible. So we need a system to be able to name compounds. So therefore, compounds are based names on the elements they make up, and there's a system. And we went through this in first year chem, and we're going to spend some time doing it because this is something that will be foundational throughout our class. But old names, so going back a couple hundred years ago, or even 100 years ago, quicklime, I have from my own notes, quicklime is calcium oxide, which is used to treat wastewater and drinking water. Epsom salt is magnesium sulfate, and it's used to put on an ache or a pain. It could also be taken internally. Milk of magnesia, its formula is MgOH2. It's used if you have an upset stomach. Gypsum is calcium sulfate. It's a common mineral. And laughing gas is N2O. So all that being said, we are going to get into naming some common compounds, and all this is review. But again, we gotta know how to do this as we continue on our class. And I really liked the way that our first year chemistry class, the way the book did this. So binary compounds are compounds with two elements, and I asked the period 2A cohort, is water a binary compound? And the answer to that is yes, water is a binary compound. I need to go grab a periodic table. The reason why water is a binary compound is because it's got two elements in it, H and O. So binary compounds, this we're going to look at first, and then we're going to get into the polyatomic ions. So, and I like the way, again, our first year chemistry book did this. So type 1 metal has only one charge. And you figure these out if it's a type 1, 2, or 3 based on their location on the periodic table. So the type 1 elements are when the first element in the formula comes from the alkali metal group, the alkali earth metal group, or this little diagonal of aluminum, zinc, silver. Some people treat aluminum, zinc, silver, especially zinc and aluminum. I'm sorry, zinc and silver. Aluminum is always treated as a type 1, but zinc and silver sometimes are treated as a type 2. So the type 1s are this column, and this little diagonal. And if you wanted to use a red or an orange marker or something to indicate that, you could. And you may not need to. So those are the type 1s. Those we just use just the name. The type 2s are, and these are elements, these are metals that have more than one charge. So they are all the other metals. They're all the other metals. Okay, so the type 1 is this column, and this little diagonal. The type 2s are all the other metals. And the type 3s are the nonmetals. Okay, and we're going to go over this today. But when it's a type 1, we're going to using just the name. When it's a type 2, we're going to have to use a Roman numeral to indicate the charge. And I'll show you, to me, actually, it was a Mr. Conyers thing. It's a really easy way that he showed me many years ago, and I still use it. And a type 3 is when we use prefixes. Okay, so it says the problem says identify the following metals as type 1, 2, or 3 using your periodic tables. So for the first one, sodium, because it's here, sodium is a type 1. Okay, the next one, calcium, same thing. Calcium's here, so it would also be a type 1. Fe, iron, is right here, so it would be a type 2. Copper is right here, so it would be a type 2. Silver is right here, so it'd be a type 2. And then nitrogen is right here, so it'd be a type 3. So how I figure out is a type 1, 2, or 3 is the location of that element on the periodic table. So Na and Ca, the first two, are type 1s. And then Fe, Cu, and Ag would all be type 2s. And then N would be a type 3. Okay, so then type 1 metal and a non-metal. So the rules center to me, they always center to me when we're naming compounds on the number of elements there are. And right now we're just looking at compounds with 2 elements. So they're binary. So that's first thing, is count the elements. If there's 3 or more elements, then there's a polyatomic ion. So for right now, we're going to come to polyatomic ions in a minute or two here. So we're going to figure out, is there a polyatomic ion or not? Right now, there's not. There's going to be 2 elements. And then the location of the first element on the periodic table, that'll be the second step, is it type 1, 2, or 3. The anion, the second ion, will always end in IDE if it's a binary compound. So you can see here, F negative is, F is fluorine, becomes fluoride. O negative 2, O is oxygen, becomes oxide. Phosphorus, P negative 3, becomes phosphide. Okay, so here, and I think, again, only in period 2 for the A cohort, I think we did these. So Li3N. So I'm going to write these on the board. Okay, so here we go. So the first one is Li3N. So what I'm saying here is kind of our progression is the first thing we do is we count the elements. Well, since this has 2, there's no polyatomic ion. And then the second step is look at the first element and determine is it a type 1, 2, or 3. Well, Li is an alkali metal, so it's a type 1. So that means we do just the name. So this is lithium. And then the second element, and the endings are important, ends in IDE, so lithium nitride. Okay, the second one, Mg3P2, and again, right now they're always going to have 2 elements, so there's no polyatomic ion. And then the second thing, okay, the first element on the period, or the first element in the formula, if I go to the periodic table, that's a type 1, so it's just the name, so it's magnesium. And the second element will always end in an IDE, so magnesium phosphide. Okay, and then the third one, Ki. So again, 2 elements, no polyatomic ion. K again is a type 1, so it's just the name. So this is potassium. And again, the second element, and again, notice everyone there is ending in IDE. Okay, so kind of the first category that we learned about back in first year chem. Okay, so 2 elements. Two elements, type 1, okay? And then here's just kind of a for your information thing, and this is actually not online. And this is, you don't need to know this, but in case of a nuclear attack, it's a really good idea to have in your house potassium iodide. Potassium iodide, as it says there, decreases the risk of thyroid cancer, and this is something you can buy at the store. I have in my notes. The plan is to give potassium iodide to people within, we just did the formula for potassium iodide, to people within 10 miles of a nuclear power plant. So far, only a few states have stockpiles of potassium iodide: Vermont, Maine, Alabama, Tennessee, Arizona, New Hampshire, New York, Maryland, Massachusetts. Colorado doesn't. We don't have a nuclear plant. Okay, that's just kind of for your information. Type 2s. Type 2 metals are named as their element name, then a Roman numeral indicating the charge of the element. And these are usually the transition metals. So when we write these out, we write their name and then a Roman numeral with the charge. So this would be iron 2 and iron 3. So when they're included in a compound, when it's a type 2, we've got to include the charge in the name. Okay, so a type 2 metal and non-metal. We must show the charge of the cation with a Roman numeral name. So here we've got to have a Roman numeral. The charge of the cation and the anion will equal 0. And this is why we take the charges and we cross them over when we write the name. So when we decide it's a type 2, we've got to write the name of the element, but we must include the charge, and we do that with a Roman numeral. Okay, so here are some examples. So again, I'm going to go back. Okay, so let's do these. Erase this. Type 2s are always the trickier one because we have to include the charge. So the first one is CuCl2. So again, count the elements 2, and so we're going to get to polyatomic ions here in a second. Step 2, copper is in the type 2 category. So that means I need a Roman numeral. So I've got copper, and I need the Roman numeral, and then chloride. Still going to end the same with an IDE ending. Okay, now to figure out the Roman numeral, this is the way that I think it's the easiest to do it, is to go back and to find the charge of the anion. So chlorine has a charge of a -1. So chlorine's a 1. Forget the negative. What you do to figure out the Roman numeral is you take the 1, you multiply by 2. You multiply by the subscript on the anion. So 1 times 2 is 2, and then divide by 1. So 1 times 2 is 2. So multiply and then divide. So what I get here is copper 2 chloride. And you got to have the Roman numeral. So you got to know if it's a type 1, it is not right to use a Roman numeral. If it's a type 2, you have to use a Roman numeral. Okay, the second one, Fe2O3. So Fe is iron. So again, count the elements, no polyatomic iron. We'll talk about those here in a second. Then, and then I locate iron on the periodic table. It's a type 2 because of its location on the periodic table. Copper was right there. Iron is right there. So that determines that. So I need a Roman numeral, and then again, it's going to end in IDE. So to figure out the Roman numeral, I'm going to find the charge on the anion. So the charge on oxygen, like we talked about in our last class, is a -2. Just forget the negative. It's 2. Again, multiply. So 2 times 3 is 6, and divide. So 2 times 3 is 6 divided by 2. This is iron 3 oxide. Okay, the next one, MgO, and I put that one in here just to kind of make sure you're going back and you're doing your steps. Count the elements 2, no polyatomic ion. Mg, well, if I locate Mg on the periodic table, Mg is right, it's right here, which is a type 1. So the name for this should not include a Roman numeral. So this would be magnesium.   oxide.   oxide.    oxide.    oxide.   oxide.   oxide.   oxide.   oxide.    oxide.    oxide.    oxide.    oxide.    oxide.    oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide.   oxide. Okay, and then the last one, Cu2O. Cu2O. So again, count the elements 2. Then I locate copper, which again, just like here, is a type 2. That means I need a Roman numeral. So I've got copper and oxide. Now to figure out the Roman numeral, I'm going to look up oxygen's charge. Oxygen is a -2. So 2 times 1 is 2 divided by 2. This is copper 1 oxide. So again, note these, and you should be able to answer the question if I ask you, why did I not include a Roman numeral here? And the reason for that is because magnesium's a type 1. Now, a really good example of this is, let's say, I'm going to just do here, let's say, what is the name of this, PbO, versus this, which is PbO2. And this is just to make sure we're good on this. Well, again, if 2 elements, if I locate Pb, lead is right here, which means if you locate it, it's element number 82. So it's a type 2. So we have lead, and I've got oxide. And I've got lead, and again, it's oxide. Well, then if I go and I look up the charge of oxygen, oxygen here is a 2. So 2 times 1 is 2, divided by 1, so this is lead 2 oxide. And again, that Roman numeral means the charge on lead is 2. Doesn't mean that there's 2 leads, it means the charge on lead is 2. And here again, oxygen is 2, so 2 times 2 is 4 divided by 1. This is the Roman numeral 4. It's lead 4 oxide. So again, the Roman numeral tells you the charge. It does not tell you how many atoms there are. So that's always a little bit of a tricky one that you guys should review, and that's why I've given you all this practice. Okay, now the polyatomic ions. Okay, so back to the notes. Okay, page 66 has the polyatomic ion table, and this, you've got to memorize this, and I want to go over this, and I want to kind of complete this and review this with you. The polyatomic ion table, okay? And this again, this is a list you're going to have to memorize, but the rules revolve around the name of the version, the polyatomic ion that ends in 8. That ends in 8. Okay, and if you look on this that I gave you, and again, you should remember for yourself, the only positive polyatomic ion is ammonia. Okay, all the others are negative. And so I want to fill in the BRs and the Is, but again, everything is based off the 8 version. So ClO3 is chlorate. So below here, where it says BrO3, negative, and if you go back and you look these up, these are both halogens. So they're going to, chlorine and bromine are both halogens. So they're going to react, they're going to be very similar. So this is going to be bromate. Since this ended in 8, this is going to end in 8. Okay, when there's one less oxygen, than the 8 version, it ends in ite. So ClO2 -1 would be chlorite. So then down here, which you guys can then fill in on this, then BrO2 negative. Again, one less oxygen than the 8 version becomes ite, bromite. Okay, so it's kind of like if you know the 8s, then you know the ites, because one less oxygen than the 8s are the ites. Okay, when there is one more oxygen than the 8s, ClO4, so when there is one more oxygen, you put on the prefix per. Okay, so when there's one more oxygen then the 8 version, you put on the prefix per. So if I have BRO4 negative 1, hopefully you can follow along. This would be per bromate. Okay, so again, everything based off the 8 version. So if we have one less oxygen than the 8 version, we drop the 8 ending and we make it ite. Okay, if we have one more oxygen than the 8 version, we put on the prefix per. Now, if there's 2 less oxygens than the 8 version, 2 less oxygens, then what you do is you put on the prefix hypo off the ite version, hypochlorite. So then BRO negative, same thing. So when there's 2 less oxygens than the 8 version, you still use the ite version, but you put on the prefix hypo. And I want to kind of just spend a minute reviewing this in class on Monday, Tuesday, just making sure, because the polyatomic ions are definitely a big deal. And so let me just get to the next page of our notes. And I'm not going to go too much longer here. Okay, so we've done that. We talked about the polyatomic ions. So if a polyatomic ion exists in a compound, you don't change the name of the polyatomic ion. So this is why I told you the first thing that you want to do is you want to go back and you want to count the elements. And if there's 2 elements, if it's binary, then there's no polyatomic ion. And all these have 3 or more elements, so there's a polyatomic ion. And the thing about polyatomic ions is they have, like the ones I just did, like ClO3, BrO4, they even though they have more than one element in it, they act as one individual unit. So this is where we're going to start class on Monday, Tuesday of next week. So what we're going to do is first of all, we're going to get you in lab groups. We're going to talk about lab safety, lab drawers, and I'm hoping we're going to finish chapter 2 in class. I don't know if we're going to get done or not, but anyways, that's going to be the plan. We'll just see. You guys have those worksheets. I'm going to post the answers to those. Those are just practice. I'm not going to collect those. And the quiz, we're going to see. I might need to make those due on Monday, Tuesday, not the upcoming Monday, Tuesday, so not August 31st and September 1, but the following Monday, Tuesday. And if you're done, you can give it to me on Wednesday, Thursday. It just depends on how far we get in class. Guys, have a good weekend. Thanks for your work. You guys are doing good, and hopefully we can continue to meet. Hopefully we can do 5 days soon. Have a good weekend. Bye.